Okay, it's revision extra video for algebra. So, first question, if A is 4, B is -1, C equals 3, evaluate AB plus BC. Keep BIMDAS in mind. So we substitute our values for A is 4, B is -1, B is -1, and C is 3. And the first thing we need to do is multiply 4 by -1, and we get -4. And we multiply -1 by 3, and that's -3. So that's the same as -4, and +1 by -3 is -3. -4 minus 3 is -7. Second one, a squared plus bc minus c. So we're going to evaluate that by substituting in these values here, where we see a, b, and c. So that means we've 4 squared plus -1 in brackets for the b, and 3 in the brackets for the c, minus 3 in brackets. Okay? So if we're going to follow the BIMDAS rule, we'll work out what the BIMDAS, we'll look at the indices. Okay, this is for brackets, but that usually refers to fix, say, 3 plus 4 first before you look at the indices. So it would be like 7 squared. So in this case we have 4 already solved in the bracket, so we'll work the power, get 16. 4 squared is 16, 4 fours is 16, plus -1 by 3 minus 3. So we just remove the bracket there for that. And then we have 16 plus, we'll work out this multiplication first, following the m here, and we get -1 by 3 is -3 and -3 there. So that's 16 plus by minus is -3, -3 is 16 minus 3 is 13, minus this 3 is 10. Let's simplify 12 times p plus q minus 5 minus 8 times p minus 2q plus 1. So that's 12p plus 12q minus 60 minus 8p plus 16q. Minus 8 by minus 2 is plus 16, and minus 8 by 1 is minus 8. Gather your like terms. So gather your 12p and your minus 8p from here, your 12q and your plus 16q from here, and your minus 60 there and your minus 8 there. And then 12 minus 8p is 4p, 12q plus 16q is 28q, and minus 60 minus 8 is minus 68. Let's simplify x plus 2 times 2x squared minus 3x plus 1. So x by 2x squared is 2x cubed. X by minus 3x is minus 3x squared. X by 1 is plus x. 2 times 2x squared is 4x squared. 2 times minus 3x is minus 6x. 2 times 1 is 2. Gather your like terms from the highest indice down. So we've 2x cubed, we've no other x cubed terms. We've minus 3x squared plus 4x squared. Then we have plus x minus 6x, and finally we have plus 2. So that's the same as 2x cubed, minus 3x squared plus 4x squared is plus 1x squared, plus x minus 6x is, minus 5x squared, minus 5x, and plus 2. So the answer is 2x cubed plus 1x squared minus 5x plus 2, i.e. plus x minus 6x is minus 5x. Okay, so let's solve 6x minus 3 equals 4x plus 7. So let's gather our x's to the left, so that's 6x minus 4x, because that comes over and changes its sign, plus 7 plus 3. The minus 3 crosses the bridge, becomes plus 3. So 6x minus 4 is 2x, 7 plus 3 is 10, x must be equal to 10 divided by 2 is 5. 8 by x plus 3 equals 4 by x plus 2. So that's 8x plus 24 equals 4x plus 8. 8x minus 4x is equal to this 8 minus that 24. 4x is equal to minus 16. So x is equal to, divide both sides by 4. They'll cancel. Minus 16 over 4. Minus 16 over 4 is 4 goes in once, because in there 4 times minus 4. Solve and graph this inequality. So we have 3x minus 3 is less than or equal to 4x plus 2, where the solution x is an element of the set of integers, so that's whole positive and negative numbers. Okay, So this means that when we're dealing with integers, that we're going to use dots to represent our solution rather than a really thick line for the real number solution. Okay, so we'll start off by writing out the inequality. 3x minus 3 is less than or equal to 4x plus 2. So that means that 3x minus 4x is less than or equal to 2 plus 3 on this side. So 3x minus 4x is minus x. That's less than or equal to 2 plus 3 is 5. We don't want our solution to be minus x. We want this to be plus x. So we multiply all terms, both sides, by minus 1. So minus x by minus 1 is x. 5 by minus 1 is minus 5. But having done that, we need to remember to switch the sign. It was going this way, now it's going that way. So the solution is x, all values of x greater than or equal to minus 5. So we draw our number line, and we note that because x is greater than or equal to minus 5, we include minus 5 with a dot, minus 4, minus 3, minus 2, and an arrow to show people that we know that it's all the values up along there on the number line. Okay, if we subtract 4 from a number, x, and then multiply the result by 5, so the number is x, subtracting 4 from it is x minus 4, and if we multiply the result of that by 5, our result is 15, so all that's equal to 15. So taking 4 from x and multiplying all that by 5 is 15. Find the number. So we have 5 times x minus 4 is 15, so 5 by x is 5x, 5 by minus 4 is minus 20, is equal to 15. So 5x is equal to this 15 plus that 20, 5x is equal to 35, x is equal to 7. Okay, let's factorize a squared minus a. All we do is take out the term that's common to both, the highest common factor of both this term and that term is a, take that outside, a goes into a squared, a times and goes to minus a minus 1 times, i.e. what we used to do in class was we'd say a into a squared over a minus a over a, and that would cancel with that, and that would cancel with that to give us a 1, a into a minus 1. Okay. Let's factorize, that was done via the highest common factor, the HCF. Let's factorize 3ax plus 4by minus 6bx minus 2ay by grouping. Okay, so I'm going to look at this and I can see really that the 3, I can start off by trying to factorize by grouping these two together, but that's not going to work. I can see that if I put my 3ax with my minus 6bx, that should work, 3 will go into 6. And my 4by and 2ay should work, because 2 will go into 4. Okay, so I'll group them like that. I'll group the first beside the third, and the second beside the fourth. Make sure I just keep the signs. So, to find the highest common factor of 3ax and 6bx, it's 3x, and divide 3x into 3ax, I get a, and into minus 6bx, I get minus 2b. And then the highest common factor of 4 and 2 is 2, and of by and ay is y. So I divide, so I write plus 2y, brackets, and then I divide 4by by 2y, and I get 2b. And I divide minus 2ay by 2y, and I get minus a. So that looks like 3x times a minus 2b plus 2y times, now what I've done here is I've changed 2b minus a. I've switched that so it looks more like minus a plus 2b, which kind of resembles the a minus 2b here. All in order, but not the same signs. So to finally fix the signs, I'll multiply these three terms by minus 1. In other words, I'll change their signs. So then I'll have 3x by a minus 2b, which is as it was, but instead of plus 2y minus a plus 2b, I'll have minus 2y by plus a minus 2b. So now this looks like the same factor over on this side. So my standout factors are a minus 2b, and my other factor is 3x minus that 2y. So these are the factors. Now we'll factorise 13x squared plus 25x minus 2 using the guide number technique. So 13 by 2 is 26. The first factors I get with that are 1 and 26. I'm looking to make plus 25. I'll use different signs because that's negative, so I'll use a plus and a negative. So I'll use plus 26 and minus 1, and that will give me plus 25 here. So I rewrite this term as 13x squared plus 26x minus 1x minus 2. And I'll group those by taking out the 13x from this term here, and I'll get x, and I'll divide 26x by 13x, and I'll get plus 2. I'll take minus 1 out here, and minus 1x divided by x is x, and minus 2 divided by minus 1 is plus 2. So my standout factor is x plus 2, and my other factor is 13x minus 1. They are the factors of that quadratic. Factorise 9 minus 49p squared. So this we'll solve this using the difference of two squares. So we'll just write our two brackets, and our plus and our minus. We'll find the square root of that term is 3 and 3, and the square root of 49 is 7 and 7, and the square root of p squared is p and p. Simplify x squared minus 2x all over x squared plus x minus 6. The solution to this is to factorise above and below the line. So factorising this above the line, we'll use the highest common factor. We'll take out that highest common factor of these two terms, which is x, and I get x by x minus 2. Then for below the line, I'll use the guide number technique to factorise this quadratic, and I'll work with the factors 3 and 2. I'm looking to make plus x, so I'll have plus 3 and minus 2. And if I factorise x squared plus 3x by grouping, I get x into x plus 3 minus, and I'll factorise these two terms, and I have minus 2 into x plus 3. The minus 2 is the highest common factor of 2 and 6, and it leaves me with x plus 3. So my standout factor here is x plus 3, and my other factor is x minus 2. So I'll rewrite this so that x squared minus 2x over x squared plus x minus 6 is actually the same as its factors. Okay, so the factors on the top are x by x minus 2, and the factors on the bottom are x plus 3 times x minus 2. They will cancel, so I'm left with x over x plus 3. So that's this problem simplified down to that. Now, express as a single fraction 5x minus 1 over 4 minus 2x minus 4 over 5. Well, we do these by finding the lowest common multiple, draw a line, write that under, and do 4 containers, 2 for the first, minus, and 2 containers for the second. We'll put this value into the first here, and this value into the third, and then we'll say 4 goes into 20 5 times, and we'll say 5 goes into 20 4 times. So we actually have 5x minus 1 by 5 and 2x minus 4 by 4. So 5x by 5 is 25x, and minus 1 by 5 is minus 5. And then we'll just keep this safe here. We'll say 2x by 4 is 8x, and minus 4 by 4 is minus 16, and there's that minus sign outside. Be careful of that always. So we have 25x minus 5, and we'll break open the bracket, minus 8x, and minus 16 is plus 16. So 25x minus 8x is 17x, and minus 5 plus 16 is plus 11, all over 20. And over here is another one, express a single fraction, 2x minus 3 over 2, plus x minus 1 over 4, minus 5 over 6. So here the lowest common multiple of 2, 4, 6 is actually 12. Draw a line, put 12 underneath. This time we've a pair of containers for the first term, plus a pair of containers for the second, minus a pair of containers for the third term. And we do as we did before. We say 2 into 12 goes 6 times whatever's there, 4 into 12 goes 3 times whatever's there, and 6 goes into 12 2 times whatever's there, which is the 5. Work all those out, and you'll end up with 5x minus 31 equals 12. Let's solve an algebraic equation with the fractions 3x minus 1 over 6 minus x minus 3 over 4 is all equal to 4 over 3. So we don't use containers in ones like these where we have the equal sign. We're looking to solve. We're looking to find a value for x, because this is an equation with the equal sign and the word solve. So we find the lowest common multiple and we multiply every term by that lowest common multiple of 6, 4 and 3, which is 12 over 1. Okay? And we look to cancel. When we set it up like that, we say 6 goes in there once, goes in twice. We end up with 2 by 3x minus 1. 4 goes in there once, goes in 3 times. So don't forget minus sign as 3 times x minus 3 is equal to 3 goes in there once, goes in there 4 times. So we get 4 times 4. So 2 by 3x is 6x. 2 by minus 1 is minus 2. Minus 3 by x is minus 3x. Minus 3 by minus 3 is 9. And 4 fours is 16. So gather your x's. 6x minus 3x is equal to this 16, plus the 2 from here, sign changed, minus the 9 from here, come over the bridge, sign changed. So it's 3x equal to 9, x is equal to 3. Let's make z the subject of this formula, which is x is equal to y minus 2z over 3. So I always, when I do a z, I always put the bar through it so I don't mistake it for being a 2. Okay, so the way we approach these ones is we balance up our equations. So we actually put x over 1 is equal to y minus 2z over 3. And then we look for the lowest common multiple of 1 and 3, the LCM, that's equal to 3. And we multiply all terms, that's one term, and that's the other term, by 3 over 1. We look to cancel, nothing cancels there, so we have 3x is 3x. Here 3 goes into 3 once, we just have y minus 2z there. Now we can look to rewrite the formula in terms of z. Now that, as I said, we've flattened this fraction into a nice flat line equation with no fractions. So we have to now consider what's happening to z. Okay? So what's happening to z is that z, first of all, has been multiplied by 2, okay, and y has been added to it. So our solution will mean that the first thing we do is we minus y from both sides, because plus or minus a term we do to both sides of the equation, and after that we'll look to cancel, if anything cancels, and after that we'll divide all the terms by 2. If we multiply or divide a term, we do it to all the terms. Okay? So 3x minus y is equal to y minus 2z minus y. And these two will cancel. So we rewrite that as 3x minus y equals minus 2z. What's left here? Now we need to divide all the terms by 2. So 3x minus y over 2 is equal to minus 2z over 2. And these will cancel. So we're left with 3x minus y over 2 is equal to minus z. But we can't leave it like that. We need to rewrite it so that we have z is equal to, and the easiest way to do that is to look at your two terms here, and this is plus 3x, so that changes to minus 3x, and this is minus y, and that changes to plus y. So you just change the two signs of these on top. So the answer is z is equal to y minus 3x all over 2. Okay. Let's divide 2x cubed minus 3x squared minus 12x plus 20 by 2x plus 5. 2x goes into 2x cubed x squared times x squared by 2x is 2x cubed, x squared by 5 is plus 5x squared. Draw the line, change the sign. Minus 3x squared minus 5x squared is minus 8x squared. Bring these down. Minus 12x plus 20. 2x into minus 8x squared goes minus 4x times minus 4x by 2x is minus 8x squared. Minus 4x by plus 5 is minus 20. Draw the line, change the sign. They'll cancel. Minus 12 plus 20 is 8x. And bring down your 20. 2x into 8x goes plus 4 by 2x is 8x, plus 4 by 5 is 20. Draw the line, change the signs. They'll both cancel. You're at the end of the problem. Solved. Okay, last one. Solve for x and y. We have two equations. 5x plus y is equal to 19. 2x minus y equals 2y minus 2x. So we have two equations there. The first one is good to go in our solution. We can work with that. But the second one we need to clean and tidy. Okay? So what we'll do is we'll fix it by, we'll start by writing it out first. 2x minus y equals 2y minus 2x. So bring over your x's and your y's over the bridge so that we have 2x plus this 2x minus y minus this 2y, which crosses the bridge, the sign change, is all equal to 0. Okay, so 2x plus 2x is 4x, and minus y minus 2y is minus 3y. Now I have a second equation that has an x term, a y term, and a constant value even though it's 0, like the one here, which has an x term, a y term, and a constant value. So I can look to solve these two equations, but you know, I always try and nail the y. I can't nail the y unless the numbers beside the y, the coefficients are the same and the signs are different. Signs are different, but the numbers are not the same. So I need to multiply this top line by 3. So 3 by 5x, 15x, 3 by y is 3y, 3 19s are 57. Now I can write one over the other, draw the line, and I can say 3y minus 3y is good luck, goodbye. 15x plus 4x is 19x, 57 plus nothing is 0. So x must be 57 divided by 19, x equal to 3. I take this value and I bring it up and I substitute it into my first equation here. So 5x plus y equals 19. I put my 3 in there, so I have 15 plus y is 19. Y is equal to 19 minus 15. Y is equal to 4, and I can check that by just putting it in any equation, any of the ones I've worked with, and they should all work out. So in this case I've chosen this one. So 4 by 3 minus 3 by 4 is 0. 12 minus 12 is 0.